In electronics, you will hear many times people talking about bypass capacitor. This capacitor connection is probably the most common one, and you will see this in almost all the circuits. A bypass capacitor is basically a capacitor that shorts AC signals to ground so that any AC noise that may be present on the DC signal is removed, producing a much cleaner and pure DC signal. A bypass capacitor essentially bypasses AC noise that may be on the DC signal, filtering out the AC so that a clean, pure DC signal goes through without any AC ripple. For example, you may want a pure DC signal from a power source. This is a transistor circuit. A transistor is an active device, so in order to work, it needs DC power. This power source is VCC, and in this case VCC is equal to 15 volts. I will not explain the functionality of the transistor in great details, because that would go beyond the scope of this lecture, but basically a transistor is a 3-terminal device that consists of the following terminals: collector, emitter, and base. If the base emitter is forward biased, meaning that the voltage at this point compared to the ground is greater than usually 0.7 volts, the transistor will open up and let current to flow from collector to the emitter all the way down to ground. In this configuration, the base emitter voltage will be around 0.7 volts, so basically you can look at this transistor like it's not even here, it's just a piece of wire connecting RC with RE. So don't worry if you don't understand the working principle of the transistor, because it's not the point of this lecture, and we will have dedicated course where I will explain to you everything that you have to know about transistor, and we will look at some interesting circuits using this component. This 15 volts provides power to the transistor so that the transistor can amplify signals. Yes, one of the features of the transistor is that it can amplify AC signals. Again, don't worry about this for the moment. And we want these 15 volts to be as purely DC as possible, although we obtain our DC voltage VCC from a DC power source such as a power supply, and the voltage isn't always purely DC. In fact, many times the voltage is very noisy and contains a lot of AC ripple on it, especially at the 60 Hz frequency, because this is the frequency at which AC signals run in many countries, right? So although we want a pure DC signal, such as this one, many times we get a noisy signal that looks like this. A DC signal such as this is actually very common. This is undesired because it adds noise to the transistor circuit, and therefore this noisy DC signal will be imposed on the AC signal. So the AC signal, which may have music or some type of recording, will now have much more noise. This noise which is on the signal is AC ripple, and many times when using a DC power supply connected to an AC power outlet, it will have some of the AC noise transfer to the DC power voltage. AC ripple can also appear from other sources, so even batteries can produce noise. To eliminate this AC ripple, we use a bypass capacitor. So our transistor circuit will have a bypass capacitor added to it. A capacitor is a device that offers a tremendously high resistance for signals of low frequencies, right? I think I repeated this enough times. And therefore signals at low frequencies will not go through them. And this is because signals always take the path of least resistance. Therefore, they will instead go through the resistor RE. And remember again, this is for low frequency signals, which is basically DC signals. However, capacitors offer much less resistance at high frequencies, so AC signals will go through the capacitor and then to ground. Therefore, DC signals will go through the resistor Re, while AC signals will go through the capacitor, getting shunted to ground. So AC signals get shunted to ground, and this is how we have a clean DC signal across our circuit, while AC noise imposed on it is bypassed to ground. So a bypass capacitor blocks the DC from entering it by the great resistance it offers to the signal, but accepts the AC noise that may be on the DC line and shunts or bypasses it to ground. And basically this is how bypass capacitors work. Now you may wonder how to choose the value of the bypass capacitor. As a rule of thumb, the value of the bypass capacitor should be at least 10 times smaller than the resistance across the emitter resistance, which is Re, at the lowest frequency intended to be bypassed. I think this is all for the moment. We will come back to the circuit in the future, and I will give you further explanations about how to choose the value of the capacitor and how this circuit works and what's the purpose of this circuit. Thank you for watching and see you next course.